Today we are solving the question 1011, capacity to ship packages within D days. Right, so the question has given us weights and we have to ship all these weights on a ship within 5 days. Right, so what we have to return is the least weight capacity of the ship. Okay, so we need to return the minimum capacity of the ship per day. Right, now how this is a binary search question. How do we know this is a binary search question is how do we know this is a binary search question? Right, because let's check out the answer space. Okay, so our answer space would be like minimum weight the ship must carry. Minimum weight that a ship must carry should be the maximum weight we have, right, like 10. So if we set minimum weight to 10 for that specific example, like minimum is equals to 10. Why? Because if we set it to 10 and then ship tries or decides to carry a weight 9, it can easily do it. Like it won't stop or block the process or block the ship from doing anything, right? If we set it to 5 and then we try to take, or the ship decides to carry 6 weight, it cannot do that. So we set the maximum weight of the given in the list as the minimum weight, so that any of the weights can be carried for that specific day. Now the maximum weight should be the sum of all the weights, like if the ship decides to carry all of these weights together, like just in one day the ship decides like I need to carry all these weights, right? So this is our answer space. And sum of, now we can see that the question we now have is if we carry a weight of 10, suppose, can we carry, if we carry a weight of 10, can we carry all the weights within 5 days? Right, this should be the main question. Now we are not focused on what should be the least weight capacity of the ship. The question now is, if we carry a weight of 10 or 11 or 15, can we carry all the weights within 10 days, within 5 days? Now let's check. Okay, let's suppose our capacity is 14, right? So can we carry all the weights? So we will write it like first day we will carry 1, 2, 3 and 4. We cannot carry 5 more because it will exceed the limit for the day, which is 14, and if we add 5 it will be 15. So we will add and go to the next day. Right, now we will add 5 and 6, this is equals to 11. Now if we add 7 it will be 18, which definitely exceeds our limit. Now it's 7 and 7 to 14, so it will be only 7 here. 4th day it will be only 8, 5th day it will be 9, and 6th day it will be 10, right? So we can easily see that it has exceeded, like there is 6th day, but we have to carry all these weights within 5 days, right? So we cannot, like if we carry the weight of 10, or if we carry a weight, if we have, let's change this question, if we have a capacity of 14, let's say, can we carry the weight? The answer can be only two possible thing, yeah, no or yes. Only two things are possible, right? So just wait a second. Only two answers can be possible, right? So if we have a capacity of 14, can it carry? No. The answer is no. This is the answer, like no. We cannot have a capacity of 14 and carry all the weights within 5 days, right? So all the answers, like if it is not possible 14, can it be possible for 13? No. Rather, if we go towards this direction, if we go and move towards and check for capacity on the left, the days are going to increase only, it won't decrease, but we have to do it within 5 days, right? So let's check it for 15, right? So we will write, can we carry? No. So we will, on in 15 we write no. So let's check for 15. For 15, if we do it, we can add 5 here, right? And 6 and 7 will be 13, 8, 9, 10, and of course there is no need for 6th day. All the weights are successfully carried within 5 days. So we will have a first value of true. So now only we discuss that all the values on the left won't be able to do it. Okay. Now, since 15 is able to easily do it within 5 days, 16 will also be able to do it successfully in 5 days. And every value from 15th onwards will be easily able to do it within 5 days, or rather even more less days, right? So can we see something here? Like, do we observe something? Like, there is this certain pattern, like all the values before 15 were no, and all the values after 15 and with 15 are true. So this is called monotonic behavior, right? This is called monotonic behavior. Since this is a monotonic behavior, we can see like we can see a certain order in our answer space. We can see a certain order in our answer space. We just have to find this first point where it gets true, and after that all points are true, right? So we see certain order in our answer space, hence we are using binary search. Okay, hence we are using binary search. I hope I am able to like point out the main pain point here, right? I think it is very confusing for people solving it for the first time. Now let's try to code this problem out. Okay, so let the leftmost pointer be max value of weights, rightmost pointer be sum of weights. Now while left equal to right, we will find the midpoint of the capacity. We are doing this for the capacity, right? This is this thing, this. So let's write it as capacity, and left plus right minus left by 2. So few people might ask, why are we not doing this? And I have explained in previous video as well. Like we can do this, and this will give it would cause no problem if you are using Python, but if you are using Java or C++, this might give integer overflow. So to prevent integer overflow, if like left and right like the list or array has a huge value like 10 to the power 6 or something, or 10 to the power 4, anything which is huge, and if we add them, this will cause an integer overflow problem. But it is fine if we are doing it in Python. So now we have a capacity, and now we will have to check the feasibility if our capacity can carry all the weights within those days. So we will do is we will find days, 2t days, and we will write w weights and capacity. Right, now if this function returns us the number of days with each capacity. So if days is less than or equal to, or let's just do this, def t days self so we will have days equals to 0 for w in weights. So now please wait carefully, like very carefully. So this is days, and days we will start with 1, not 0. There has to be a day 1, there is no day 0. So current value is 0. Okay, so we'll come inside this, and if the current value plus the weight is more than the capacity, we will do is like we will increase the day, we will move on to the next day. Like if the capacity for a certain day, like come here, we see like for the first day we add weight 1, right? So wait, and I'll explain you in a second, just let me code this out first. So now we have written like if the current plus weight is more than capacity, right? So here the capacity is 15 and current weight we have is we are on index 1, right? We have 1 and current weight is 0. Now we want to add 1. So first we will check. So we'll add current, which is 0 plus whatever weight we have, and we will check if this is bigger than 15. No. So we will come here and add this, right? And current will be 1. Now we will move to another weight, which is 2. We'll add 2 to this. Now it's 3. Is 3 greater than? No. So we'll do this and we'll make this 3. Now we will go to 3. 3 plus 3. Is it greater than 15? No. So we will do this and we'll make this 6. Right. Next we have 4. If we add 4, is it greater than 15? No. So we will put 4 here and it will become, current will become 10. Now we'll add 15, right? Is 15 greater than 15? No. No. So we will add 5 here and we'll get 15. Now we have value of 6 here. So if we add 6, is it greater than 15? Yes. So we will increase the number of days we have. Right now we had days is equals to 1. Now since it is like greater than 15, so we cannot carry it that day, no. So we will have to increase the number of days, and now the current will, like we can see now, if the current of weight is greater than capacity, we will increase the number of days and current is equals to W. We will start with that day weight for that day, like 6. Now current is also equals to 6. Now we will have next weight as 7. Now if we add 15 plus 6 plus 7, what will we get? 13. Is 13 greater than 15? No. So we'll add to day number 2 as 7. Now if we add 8 to 13, like 8 after 7 we have 8. So if we add 8 to 13, is it greater than? Yes. So we will increase the day here. Okay, we will increase the day. We will shift the current to 8 and we will add it to the third day, 8. I hope I am able to explain this right. Okay, so if the number of days returned from here, the day returned from here is less than or equal to days that are provided to us, required days is less than number of days, then we want, if the required days that we have is less than the days, we want to reduce the capacity, right? Let me explain. Like number of days, if here number of days is 5 and here something is less than 5 and here something is more and more less than, right? The values are decreasing, number of days in this direction is decreasing. So we wish, like we are somewhere here, so it's decreasing, so we wish to shift our search only in this direction, like beyond this. Here the value is very less than number of days, like day might be 3, 2 or 1. So we have to shift our search towards the left side so that the number of days can increase. So what we will do is write is equals to capacity minus 1. Okay, so to narrow down our search towards the left side, and else what we will do is left is equals to capacity plus 1. So what we are doing is, if the number of days, like here the number of days required was 6, so we have to move in this direction, we have to search in this direction to reduce the number of days. Okay, so here it was 6 and here also it was 6 and here it might be 7 or something. So we will do this thing. Now we will reduce, we will return L. Why we will return L? Because the value L and R will cross and L will be the only valid least capacity we have. Let's talk about time complexity, right? Since we are using binary search on the answer space, in the first iteration would be n, in the next iteration would be n by 2 and next would be n by 4, and we know this behavior only happens when we are big of log n. So we cannot like directly say it to be n, it would be log base 2 maximum of weight, that is the min that we have set here, this thing minus like sum, like this right thing, because we are only traversing between these values. No, we are only traversing between this value now. So we max weight, right? So this should be the time complexity of binary search, but we are also doing a feasibility check here. Since we are doing a feasibility check, we are traversing to all the w's in the weight, right? We are going to each weight in this list. So we will do like n, which is the length of the list, into this. I think this makes sense because we are doing it inside the binary search, hence we have to multiply it. Now space complexity. Space complexity should be big O of 1, right? Because we are not using any additional data structure in our entire code. I hope this code works. Let's see. Okay, so there's something I have not commented out. Invalid syntax. I have not commented on this. tdays is not defined. Self dot yes. Please use self, else Python won't be able to find the method in this solution, in this entire class. So we can see that all the solution is got accepted. Let's see and try submit this. It got accepted. Congratulations everyone. I hope this video was helpful. If you have any comments, do write it down in the comment box down below, or any improvement suggestion that you have. Thank you.